Good evening, because in my case it's the evening, linear algebra students. This is the section subspaces of Rn, and you have to put down this theorem in your notes, and it has to be filled. So this is the YouTube video with which you can do it. Let's read the theorem and read the comments. First, given a set of vectors from V1 to Vk in Rn, and S to be the span of these vectors, okay? Then that's it. The span of these vectors is automatically a subspace of Rn. We will do the proof for two vectors. The reason is simply because doing it for a general number of vector is notationally tedious and not very insightful, not more insightful than just doing the proof for two vectors. And if you can do it for two vectors, you can easily generalize it to the number of vectors you wish. To do this proof, we need this theorem, okay, that we have seen in class. S is a subspace if and only if S is not empty, and this property holds. So if U and V are in S, CU plus DV are in S, regardless of CD in R, and regardless, of course, of UV in S, okay? In other words, like, this is the statement that a subspace is a non-empty set that contains all its linear combinations. So let's get going. 1 is easy. 2, we have to be careful. Okay, so let's start with 1. Let S be equal the span of two vectors, V1, V2. Okay? Okay, perfect. I'll use V1, V2. I think it's good. So obviously, I'm going to put the 1 here. So V1 and V2 are elements of S. So S is not empty. So 1 is as easy as that, right? Since V1, V2 are in S, S is not empty. Okay, so 1 is verified. Now, number 2, okay, it's a little bit more complicated because what we have to do is to prove that if U and V are vectors in S, then this is also in S for every CD in R, okay? So we're going to call these vectors a little bit differently. We're going to call them U1 and U2 instead of UV. So suppose that U1 and U2 are two vectors in S. Vectors in S. So what does it mean? It means that U1 is a linear combination of V1 and V2. So we could write, for example, that U1 is equal to, and now we need appropriate letters. That is a little bit, so let's say SNT, RNT. Let's call these letters RNT. So it means that U1 will be equal to R1 V1 plus R2 V2 for some R1, R2, like for some real numbers R1 and R2, you can write U1 like this. And you can do the same for U2, but it will be different parameters, okay? So U2 will be equal to T1 V1 plus T2 V2 for some, again, T1, T2 in R. Okay. So I'll erase this now. I'll try to keep the theorem, but I might have to erase it, unfortunately. Let's see. So what does it mean? Okay, let's now write Cu plus dV. Or, well, actually, what we write is Cu1 plus du2, okay? And now, obviously, now we will replace this in here. So we'll have here C times R1 V1 plus R2 V2, okay? Plus D. times, again, same thing, T1 V1 plus T2 V2. And the idea is to prove that this is a linear combination of the vectors V1, V2. That will be enough to prove that it's in the span, okay? So the only thing we need to do here, and you have done it a couple of times, is to regroup the V1s together and regroup the V2s together. Okay, so for example, let's distribute everything and let's move all the V1s together because, of course, vector addition is commutative. So we have the C1, CR1 V1 plus DT1 V1 plus CR2 V2 plus DT2 V2. Okay. Now, as you know, vector multiplication by a scalar is, I think we call this right distributive. So, but what I mean by this is that you can write this as being CR1 plus DT1 multiplied by V1 plus CR2 plus DT2 multiplied by V2. All right. Well, what did we prove? These two things are real numbers. Like what I mean by these two things is that this is like a number. Okay, so this is a real number. And this is also a real number. And as a result, so I'm forced to erase the theorem, but we're proving number 2, as you can see. So I'll try to keep 2 on the board. So it means that CU1 plus DU2 is a linear combination of V1 and V2. And this is the definition of CU1 plus DU1 being in the span. So CU1 plus DU2, sorry about the verbal mistake, is in the span of V1, V2. So in other words, what we prove is that CU1 plus DU2 is in S regardless of C and D. Of C and D in R, which means that number 2 is proven. And this completes the proof. So by the green theorem, so I will say by the above theorem, even though I erased it, but you can just see it again by looking at the beginning of the video. S is a subspace, QED. All right, I hope this video helped. You guys have a good evening, or if you watch the video in the morning, have a good morning. See you in class or in the next video.